Hello, today I'm looking at M3 International A-Level May 2017. This is question 7. This is a whopper of a question. You've got 9 marks and 6 marks. Okay, so a light inextensible string of length A has one end attached to a fixed point O on a horizontal plane. A particle P is attached to the other end of the string. The particle is held at point A, where A is vertically above O and OA is little a. The particle is then projected horizontally with speed root 10 ag, as shown in figure 2. The particle is then projected, the particle strikes the plane at the point B. After rebounding from the plane, P passes through A. The coefficient of restitution between the plane and P is E. Show that E is bigger than or equal to a half. Okay, interesting. So they've mixed up a bit of M2 with M3 here. Now let's have a look at what is happening then. So I could look at the energy here and the energy here, and then I could work out what the speed is when it hits B. So the energy at the top, kinetic energy at A, plus the gravitational potential energy at A, will be conserved and will be equal to the kinetic energy at B. And basically I'm considering that this level is where there is no gravitational potential energy. So popping everything in, I've got half times the mass. Now in this question they didn't tell me what the mass was, so I'll just call it M, times U squared. That will give me 10 ag, plus mg times the height above the this level, so that's A, equals half m v squared, where I'm taking v to be the speed at B as it hits the surface. So I can divide everything by m, I can multiply everything by 2, and so I end up with 10 ag plus 2 ag, so that's 12 ag, is v squared. So v will be the square root of 12 ag. Now, so that is the speed with which it hits the plane. So then what will happen? As it rebounds, well, if it hits the plane with this speed, so hits plane at B with speed this, then it will rebound from B with speed E times this. Okay, now then they also told me that it goes through A as it rebounds. So basically that means that it has enough energy to be able to stay moving in a circle, so the string doesn't go slack. So basically I think that is where I'm going to get my inequality from, either by assuming that t is bigger than or equal to 0, or by assuming that the velocity at the top is big enough. Now let's use the tension. So at the top, what forces are going to be acting? So when this particle is at the top, then I'm going to have the tension acting towards the centre of the circle. I'm also going to have the weight, and I know that at the moment the acceleration will be the speed squared divided by the radius. The radius is a, and let's say the speed when it gets back up to the top is x. Okay, now so I need to be able to get x to be able to use this. Hang on a sec. So let's just write down Newton's second law and write down what we've got. So T plus mg equals mass times acceleration. And I know that T is bigger than or equal to 0. Therefore, I know that this stuff minus that stuff is bigger than or equal to 0. So mx squared over a minus mg is bigger than or equal to 0. I could divide everything by m, because I know that m is positive, so it doesn't change my crocodile, as it were. And then I get x squared is bigger than or equal to, that will be g, that will be a. Okay. So let's have a look at the energy equation then as well. So basically what I'm going to say is the kinetic energy as it leaves B will be equal to the kinetic energy that it has when it gets back up to the top plus the gravitational potential energy when it gets back up to the top. So where was I? Right, this was the speed with which it rebounds, so the kinetic energy will be half times the mass times this squared. So I've got E squared times 12 ag, and that will equal the kinetic energy at A, half times the mass, and I called that speed when it's up there x, so I've got x squared plus the gravitational potential energy, which will be mg times the height above the above O, so that will be A. Now, I know that x squared must be bigger than or equal to GA, so if I can rearrange this thing to give me x squared, then I can say that that expression is bigger than or equal to GA, and essentially eliminate x from here. So if I divide everything by m, double everything, then here I end up with x squared is this thing, 12 e squared ag minus 2ag, and then I know that x squared is bigger than or equal to GA, so therefore I know this thing is bigger than or equal to GA. So I end up with 12 e squared ag minus 2ag, so x squared is bigger than or equal to GA, using that expression which came from assuming that the tension at the top is bigger than 0 or equal to 0. So dividing everything by ag, because I'm sure that a and g are both positive, then I can add 2 to both sides. So here I'll get 1 plus 2, 3. Here I'll get 12 e squared, and so I'll get e squared is bigger than or equal to 3 divided by 12, which is 1/4. So that gives me e squared, and so therefore e will be bigger than or equal to 1/2 by square rooting this. You do need to be a little bit careful with this kind of inequality. If e squared is bigger than 1/4, then e could be bigger than 1/2 or less than minus 1/2, but because we know that e is positive, then you can ignore the negative part of that solution and just take this as required. Okay, so that is the first part of the question, and that is 9 marks. Phew! Then it says the point C is above the horizontal plane such that OC is equal to A. So in other words, C is on the circle, and angle COB is 120 degrees. So let's just try to understand what that looks like. Okay, so they said OC is above the horizontal plane and COB is 120, so it must be over here somewhere. Okay, and as the particle reaches C, the string breaks. The particle now moves freely under gravity and strikes the plane at point D. Given that E is this, find the size of the angle between the horizontal and the direction of motion of P at D. Yuck. Okay, so let's get it really clear what this looks like. So they told me that this is O, this is B, and then there's this point C that's over here, and they told me that this angle is 120. So if I do 120 minus 90, then it tells me this angle here is 30 degrees. And when and this length is A, and this point here is C. Okay. So when the particle reaches C, the string breaks. The particle now moves freely under gravity and strikes the plane at point D. So it's basically going to leave the circle here at whatever velocity it's going at here. I'm given the value of E, and it says find the angle between the horizontal and the direction of motion. So as this hits the floor, the horizontal and the direction of motion of P at D, and so D is where it hits the floor. So let's call this angle alpha. Okay. So if this is 30, then this is 30, that's 30, so the angle there is 30 degrees as it leaves the circle. And right, okay, so when it's here I need to know what the speed is here. Now, what did I work out? I worked out that I did the thing with kinetic energy, I did the other thing with the kinetic energy. I've got the rebound speed from the bottom, so I could work out the speed here using the rebound speed here, and that rebound speed was root 12 ag multiplied by E, and so E I now know is root 3 over 2. And so if I equate the kinetic energy at B that will equal the kinetic energy at C plus the gravitational potential energy at C. So I would have half times the mass times this thing squared. So there I would get a 4 on the bottom, and I would get, what's 3 times 12 is 36, so I get 36 Ag on the top. Then here I get half times the mass times the velocity here squared, and I think I've already used V, I've already used X, so if I call this something like W squared, plus the gravitational potential energy at C. So if this is A and this is 30, then this height is A cos 30. So I've got mg cos 30. So tidying this up a little bit, what I'm really interested in is W squared. So I can divide everything by m. I can double everything, so double, double, double. And here I get 36 divided by 4, which is 9 Ag, equals W squared, plus here I've got 2Ga times by cos 30, which is root 3 over 2. So the 2 would cancel with a 2, so I just get root 3 Ga. So then following on from that, if I rearrange this, then I'll get W is this stuff, so 9Ag minus this stuff, root 3 Ga, and that would give me W squared. So then square rooting that, then I get an expression for W, and so W is the speed with which it leaves here. So then that means that I can find out the horizontal component of the initial speed, because that will be the horizontal component of the final speed here as well, because horizontally there is no acceleration. So the horizontal component there, so we're looking horizontally, so the initial velocity here is going to be w multiplied by cos 30 and then if I look at the final speed here, the final speed that it hits the ground with here is going to be the same as the initial speed here, because if we use energy, then I've got the energy here, the kinetic energy here, the kinetic energy here, and from here to here there's been no loss of energy. There was no work done. It gained a load of potential energy, but then it lost it all again. And so I can say that this speed equals this speed here. So I know that the final speed basically, so here I've got this thing, and here I've got this thing. So that gives me root 3 times 12 is 36 ag over 2. And if I want the angle between the final speed and the horizontal, then that would be here. And so using alternate angles, that's this angle here, which is alpha. Okay, so now I just need to say that cos alpha is the adjacent, which is this thing, divided by this thing. So here I've got root 36 ag, and when I divide by all of this, that 2 will flip up to the top. Okay, because dividing by this is like multiplying by the reciprocal. So what's going to happen here is to get cos alpha, then cos of 30 is root 3 over 2. So the 2 will cancel with this 2 here, and I'll just get root 3. I've got root ag everywhere, so that will cancel out all over the place. And on the bottom I've got root 36. Up here I've got 9 minus root 3. And that will simplify, but I'm just going to stick the whole thing in my calculator. So I have that alpha is inverse cos of this thing. So I've got root 3 divided by root 36 multiplied by root 9 minus root 3, and then doing inverse cosine of that angle, I get 38.89999, so I'll round that off to 39 degrees to the nearest degree. Okay, so that part of the question was worth 6 marks. So altogether you have 9 plus 6, so 15 marks for that question. Okay, I hope you found that solution helpful. Do click like if you liked it, and good luck with your studies.